Right, so we're continuing to look at unit circle trig. Okay, in 6.2 part 1, we ended with finding the 6 trig functions of 45 degrees. And now we'll look at the 6 trig functions of 30. All right, so Isabel, in order to get the 6 trig functions of 30, what's the first thing I need to find about 30?
Its coordinates.
I've got to get its coordinate. Yep. So if we draw our unit circle, let's just go like this. It doesn't have to be perfect, but just kind of put 30 closer to the x-axis than the y-axis. So there's 30. There's my long side. And how big is the long side always in the 30, 60, 90?
Square root 3 over 2.
Always square root 3 over 2. And then here's my short side. Short side is always how long? 1/2. So by drawing it that way, I can clearly see red is the x, green is the y. So the coordinate is root 3 over 2, 1/2. Or just memorize that. 3 over 2, 1/2. Right, so we'll go through all the values. Isaac, what's my sine? Yep, 1/2. Nick, my cosine?
Square root of 3 over 2.
Square root of 3 over 2. And Jaden, to get my tangent, what am I going to do with the y and the x value? We're going to divide them. Now, when you divide them, the 2's cancel out. You can flip and multiply, but that's what happens. So the 2's are gone. I'm left with 1 divided by the square root of 3. But we can't leave it like that. Why, Connor?
Because you can't have the square root on the bottom.
Can't have the square root in the bottom. And Rebecca, how do I fix having the square root in the bottom?
You multiply it by square root of 3 on the bottom.
Yep. And when I multiply by square root of 3 in the top, I get this. When I multiply by square root of 3 in the bottom, I get the square root of 9. But that's just 3. Don't get rid of that other fraction. That might come in handy later on. But what I circled is the answer for tangent. Okay. And Kylie, what am I going to do with all of those now? Flip them. So I flip the first one. That's easy. Becomes 2 over 1, or just 2. Greta, how about when I get the secant of 30? What would I start out with?
It would be, well, you would start off with 2 over square root of 3, but it would wind up being 2 square roots of 3 over 2. Or over 3.
Yep. So 2 square roots of 3 over 3. And now the cotangent of 30, you have a choice. You could either flip the first fraction, 1 over the square root of 3, or the second one. They're equal to each other. So it doesn't matter which one you flip. Which one would be better to flip? Yep.
The first one.
How come?
Because the square root is already in the bottom.
Yeah, if you flip the first one, the square root goes to the top and you're done. If you flip the second one, that's okay, but then you're going to have to fix it. The square root goes to the bottom, and when you fix it, you're just going to get the same thing all over again. So that's your 6 trig functions for 30 degrees. Any questions on those? Okay. So the last basic one we have is the 60. Okay, that's what pi over 3 is, 60 degrees. So there's 2 ways to get the coordinate. Either memorize it, or you can make your sketch. Figure out which side is the short side, which side is the long side, and that'll tell you the coordinate. All right, so 60. Anyone give me the coordinate for 60? Yep. One half square root 3 over 2. It's the same as the 30, except the x and the y switch. Okay, so let's go through all our values. Sine is root 3 over 2. Cosine is 1/2. And tangent, you divide them. What cancels out when you divide them?
2's.
The 2's. So you're left with square root of 3 over 1. And now flip them all. These are, if you look at these numbers, we just kind of worked with numbers like this before. So we're kind of seeing the same answers again, so flipping it should be pretty quick. So I think that's the one that Greta had given us. When you flip square root of 3 over 2, you get 2 root 3 over 3. When you flip a half, you get 2. And what about when you flip root 3? Yeah? Yeah, when you flip that last one, you get square root 3 over 3. Questions on those? Now, let's compare that to what we just did. Let's get rid of that. So on the left, I have all the answers for 30. On the right, I have all the answers for 60. All right. So what do you notice if you compare all the numbers that are circled?
They're all the same.
They're the same numbers, they're just kind of in different spots. Can anybody tell me 2 functions where the answers switched places from the ones on the left to the ones on the right?
Tangent and cotangent.
The tangent and the cotangent switched places from the 30 to the 60. Okay, what else switched places? Yeah, Sean?
The sine and the cosine.
The sine and the cosine. And the last 2 that switched places were these. Now, if you just pronounce the names of the functions in the trig box, in the boxes, you'll notice a pattern. Sine, cosine. Secant, cosecant. Tangent, cotangent. So the ones that switch places are what we call the cofunctions. Those are cofunctions, what I have in the boxes. Sine, cosine, secant, cosecant, tangent, cotangent. Tangent and cotangent happen to be reciprocals, which means you flip one to get the other, and cofunctions. They're both. The other ones are. Right? But those are the ones that switch places. And we'll talk more about that later on, but that kind of behavior happens a lot. As long as the 2 angles add up to 90, which these do. You have a 30 and you have a 60. If we could do it with like a 10 and an 80, you'd notice exactly the same thing. But to do it with a 10 and an 80, those aren't numbers that are multiples of 30 or 45. So we'd have to use a calculator. All right, so let's see if we can find this, 3 trig functions of 135. I'm not going to go through all 6. Okay, we've done a lot of all 6. So let's just try the first 3. All right, so now we need to figure out what kind of triangle this is going to be. If it has something to do with the 45, 45, 90, your coordinates are going to have root 2 over 2's in them. If it has something to do with a 30, 60, 90, you're going to see coordinates with a 1/2 and a root 3 over 2. So to figure out what kind of triangle it is, look at your angle and ask yourself if it's a multiple of 30 or 45. In this case, we have 135. That's a multiple of what number?
45.
It is a multiple of 45. It's 45 times 3. So this problem is going to have something to do with a 45, 45, 90. Okay, let's see if we can find out where 135 is. Where's 135? Is it closer to 90, closer to 180, or right in the middle? In the middle. The 45s are always right in the middle. So 135 is about right there. Make a triangle out of that point. Draw a line always right to the origin, and then perpendicular to the x-axis. Right. So let's take a look at why it's a 45, 45, 90. How far is it from there to there that I just highlighted in red?
45 degrees.
It's 45 degrees. to get from 90 to 135, you add 45. So if this is 45, that means this is also 45 from geometry. That angle always matches that arc. Okay. So these are both 45. Well, if that's 45, how much is the piece on the inside? That's also going to be 45 because this makes a 90 right there. So if the top piece is 45, that piece is 45, and that means the angle at the top is how much? That's also a 45 because all the angles add up to, what do they add up to?
180.
180, yeah. Right? So we've got a 45, 45, 90 triangle. Now, what's the length of each side in the 45, 45, 90? Yep, they're both square root of 2 over 2. Now, the only thing you have to be careful when you write the coordinate is you have to take into account you went left and up. So what's my x value going to be? Yep, negative square root of 2 over 2. So negative means I went left. And then the y value?
Square root of 2 over 2.
Square root of 2 over 2. That's the only difference when you do a multiple of 30 or 45. Sometimes one of the numbers is negative, or if you in quadrant 3, they both would be. Okay, let's now go through our trig functions. How about, Morgan, what's my sine?
Negative, yeah, square root of 2 over 2.
One more time?
Square root of 2 over 2.
Yes, so it's just square root of 2 over 2. Sam, how about my cosine?
That would be square root of 2 over 2 also.
So the same thing?
Yeah. Yeah.
No, not the same thing. Close, but not quite.
Negative square root of 2.
Right, because the sine is the y and the cosine is the x. And this time they're different. So negative square root of 2 over 2. And how about my tangent? Tangent's when you take y divided by x. So it cancels out, and what do you get? Negative 1. Yep. And now if they ask for the other 3 trig functions, just flip them. But that's the 6 trig functions of 135. Okay. If you were to do, I'm not going to go through the whole problem. Just want to see if you can get the coordinate. Let's see, the next one would be 225. Right there. 225 is halfway between 180 and 270. That's a 45, 45, 90 triangle again. Because 225 ends in a 5. It's a multiple of 45. What do you think the coordinates of that would be? Jake?
Negative square root of 2 over 2, negative square root of 2 over 2.
Yeah. So now you could do exactly the same problem, except they would both be negative. And then how about this one? This is the last 45. It's the one in quadrant 4. That's 315. It's halfway between 270 and 360. What would be the coordinate of 315? Yep.
Square root of 2 over 2, negative square root of 2 over 2.
Yep. So the 45s aren't really bad because you know they're both root 2 over 2 all the time. You just have to figure out which one of them is negative, which one's positive. Or are they both positive or both negative? Okay, let's look at this one. Find the 6 trig functions of 7 pi over 6. Actually, it doesn't say 6, just 3. Okay. This is a basic one times 7. Does anyone remember what pi over 6 is? Yep. It's 30. And what's 30 times 7?
121. No, 200.
210.
210, yeah. So the angle is 210. Let's figure out the coordinate. Is 210 a multiple of 45? No. Is it a multiple of 30? Yeah, it's 30 times 7. We actually just did it. So it's going to have something to do with the 30, 60, 90, which means your numbers are going to have 1/2 and root 3 over 2s. But we got to figure out which one is which. So 180, 270. Where's 210? Closer to 180, right in the middle, or closer to 270? It's closer to 180. It's like right here. So make your triangle. And if you draw it somewhat accurately, you should be able to tell which side is the long side and which one is the short one. There's your long side. There's your short side. Long side, how big is that in the 30, 60, 90? That's your square root of 3 over 2. And the short side? 1/2. So now we're going to write our coordinate. The red is, the leg I drew in red is your x. The leg in green is your y. All right. So what do you think the coordinate is for 210? Yep.
Negative square root 3 over 2 and negative 1/2.
Yep. So it's negative square root 3 over 2, negative 1/2. And now we just go through and do all the same stuff again. So my sine, how about Devin?
It would be negative the negative square root 3 over 2.
That's my cosine.
Negative 1/2.
Yeah. So remember, cosine is x, sine is y. And my tangent, Madison, how do I get my tangent? Divide them. Divide the y by the x. Well, when I divide them, what cancels out? The 2's and the negatives. So when I divide them, I'm left with 1 divided by the square root of 3. Okay. And then 1 divided by the square root of 3. I think we've already fixed this before. What is that? It's the square root of 3 over 3. Okay. So any questions on that? So just to kind of show you how many different coordinates you should be able to do on the circle. We just talked about the 45 in each quadrant, so you should be able to find those coordinates. We did the 30 and the 60, which are the same coordinates, they just flip places. And we could do a 30 and a 60 in each quadrant. And we can also do the quadrantal angles. Those are the easy ones. Those are where all the coordinates are 1s and 0s. So if you notice there's kind of a gap. Like there's a gap, like there's one missing here, here. And if you had these, then they would all be nicely spaced. Well, the ones in red are multiples of 15. And there's one there. I didn't draw it perfect. But the ones in red are multiples of 15. We're not really talking about those yet. There's a trick to do them, but not today. So the ones in black are the ones you need to know. Multiples of 45, 30, and 60. So there's 3, 6, 9, 12, 13, 14, 15, 16 dots in black. Okay, and for any of those, the coordinates are always going to have root 3 over 2's, 1/2's, or root 2 over 2's. Every single one of them. Right? Your quadrantal angles, those coordinates always have what numbers? 1s and 0s or negative 1s. Yep. So those are the easiest ones to do. So any questions on how you would find the coordinates for any point in black? Don't worry about the ones in red. Any one of the ones in black. Okay. So what happens if you have a trig function that's not a multiple of a 30 or 45? Well, we use the calculator. So if I asked you, like, what's the sine of 42 degrees? Well, first thing I say is, okay, is 42 a multiple of 30? No. Is 42 a multiple of 45? No. So this is not one that we can do on the unit circle. So we use the calculator. And I'll show you how to do it. So first thing I have to do is check the calculator. And if I use my calculator the way it is right now, I'm going to get all of those wrong. What do I have to do?
You need to set the calculator's degrees and not radians.
Right. My calculator's in radians. The question they're giving me is in degrees. How do you know that? I don't see the word degrees anywhere.
Just the degrees symbol.
It's got the symbol. If it's got the symbol, that means it's a degree. Okay. So switch to degrees. In case I haven't mentioned it yet, you just press mode, and then it's the fourth one down. Go over to degree, make sure you hit enter, and it should change to degrees up at the top. And now you just type them all in. Sine of 42 is that. Cosine of 42 is that. Tangent of 42 is that. So technically they said to round to 2 decimal places, so that would be 0.67, 0.74, 0.90. Any questions on those? Now, they're asking me for 3 other ones. The cosecant, the secant, and the cotangent. Do I have a button on there that says CSC or SEC or COT? No, I don't have a button for it. So what did we do with this to get that?
You just
Flip it. So that's how you do it. You just flip it. 1 divided by, actually let me clear it first. 1 divided by sine 42. That's how you do the cosecant. How about the secant? How would I type that one in?
Same way you did that one.
1 divided by cosine of 0.7.
Yep, well, cosine of 42. Yeah, I'm just going back to the original problem. And I just said it, but how would you do the last one? Cotangent of 42?
1 divided by cotangent of 42. I mean tangent of 42.
Tangent, yeah. Now, why did I go back to the originals? Why not just do 1 divided by 0.67 and 1 divided by 0.74?
Because it's rounded.
Yeah, because it's rounded. So if you do 1 divided by 0.74, it's not as accurate as just keeping the original. Right? I mean, it'll come out close, but it'll be a little off. So that's how you do that on the calculator. Let's look at this one. This one's only asking for sine and cosine. You could do the others just the same as we did up above. But what do I need to be careful about? Yeah?
There's no degree symbol.
There's no degree symbol on the number, on the argument. So what does that mean?
It's radians.
It means it's automatically radians. They don't have to write radians. You have to know if it's not written, that's what you always assume. Okay, so switch to radians, and now type it in the same way.
What button did you press for that to get the win?
Same way we changed to degrees and radians, just under mode.
Oh.
Yep. Just hit enter, and it'll tell you right at the top, right here, what mode you're in, if you're using one of my calculators. Sine of 10, what's the other one they want? Cosine. And there's your 2 answers. Negative 0.54 and negative 0.84. Make sure you round properly. If it says to 2 decimal places, remember 5 or higher, you round that digit up. Okay. Any questions on using the calculator? Okay, that part's pretty straightforward. All right, so let me, all right. I'm going to come back to this in a second. There's 2 special properties, or actually 1 special property that applies to 2 of our trig functions, sine and cosine. First of all, I think I showed the graph yesterday. Well, I'm not sure if I showed this yesterday. But what you're looking at right there is a graph of the sine function. That's what it looks like. Okay. And then coming up in red right after it is a graph of the cosine function. They're both waves. None of the other trig functions look like waves at all. They're all different. But sine and cosine, they kind of look similar. In fact, one is just like a horizontal shift of the other. That's all they really are. If you look at left and right, how far does it look like these graphs go left and right? Forever. That's why the domain is negative infinity to infinity. They never stop going left and right. If you zoom out, you just see more waves. Now, how about up and down? There's a limit. Anyone think they can see how high and low they go?
It's not infinite, it's like
1 and -1. Yeah. These graphs, if I make it bigger, it's easier to see. But the graphs don't go any higher than 1, and they don't go any lower than -1. And what's that called? It's not the domain, that's the range. And these are the only two trig functions that have that exact domain and range. Now, what did we say if you get an angle that's like too big, like 550, what can you add or subtract from it in degrees to make it smaller?
360.
You could add or subtract 360 in degrees. Could I do it again? If I wanted? Yeah. You can do this as many times as you want. That's way too negative now. But you can add or subtract 360 as many times as you want, and you can do that for sine or for cosine, either one. Now, what's 360 the same as in radians?
2 pi.
2 pi. So you can add or subtract 2 pi as many times as you want, and it'll be exactly the same thing. That's what this is saying right here. If you want to take the sine of something, it's the same as taking that and adding multiples of 2 pi. N is just how many multiples you add. Do you want to add 2 pi times 1? You want to do it twice, 3 times, 4 times, or even make it a negative, and that would subtract 2 pi. Yeah.
That can only be like a whole number, right?
Yes, n has to be an integer. It can only be a whole number. So when we say like you can add a multiple of 360, you can add 360 times 1, 360 times 2, 360 times 3, but you can't add 360 times 4.5. No, it has to be an integer multiple. And same with cosine. Okay, to find the cosine of anything, you can take that thing and add or subtract 2 pi, or 360 if you're doing it in degrees, as many times as you want. I'll just put the degrees above and below it in parentheses. And that's called the periodic property. Okay. I didn't call it that when I told you it. I just said you can add and subtract 360 as many times as you want. But the name of it is the periodic property of sine and cosine. All right, so last thing we're going to look at. Okay. Any questions on, first of all, unit circle trig or these two special properties? Okay, they kind of tie in with unit circle trig, because if I asked you to like find the coordinates of 900 degrees, you wouldn't want to try to think of it as 900. You would want to think of it as 180. 180 is a lot easier to visualize in your head than 900. And that's what this property lets you do. All right. So in example 6, we kind of saw a connection between the sine and the cosecant, the cosine and the secant, the tangent and the cotangent. And the connection is you flip one to get the other. Well, there's a special name for that. If you take a trig function and you flip it to get another trig function, that's called a reciprocal identity. And the word identity means it's an equation that is true no matter what you plug into it. So what I'm saying here is this angle can be anything you want. If you take the sine of any angle you can think of and flip it, it's always the cosecant. It's not like I'm saying this formula only works for even angles, or it only works for odd angles. No, it works, it's an identity. It works all of the time. So if you flip the sine, you always get the cosecant. If you flip the cosine, you get the secant. And if you flip the tangent, you get the cotangent. Now, let's look at the first one again. If you flip sine, you get cosecant. What if you flip cosecant? It goes back to what it was. So that's not really anything new. It's just kind of like saying the same thing a different way. If you flip the cosecant, you get the sine. Right? Now, what if you took the secant and you flipped that? What would you get?
Cosine.
You'd go back to the cosine. And the last one, if you flip tangent, you get cotangent. Well, what if you flip cotangent?
Tangent.
You go back to tangent. You can just keep flipping them back and forth. And those are called the reciprocal identities. Really, if you look them up online, you'd probably just see these three, because those three are exactly the same thing. It's just kind of saying the same thing a different way. All right, so these identities that I'm giving you, these are what we call the fundamental trig identities. This is one group of them, the reciprocal identities. Okay. The next group is the tangent and cotangent identities. Can someone remind me again, when we do unit circle trig, what letter is sine equal to?
Y.
Y. Cosine? And what's tangent? Y over x. Tangent is y over x. What did we just say y is up above? What's another name for y? What else does y equal? Well, it's right there. What else is, y is the same as saying what? Yeah? Sine. Y equals sine, right? Y is the same as sine. So instead of y, I'm going to put sine. And what's x the same as? Cosine. So that means tangent is really the same as what? Tangent is the same as sine divided by cosine. And that's one of our tangent identities. So, like, just as an example, let's say you wanted to know the tangent of 12. Okay, and you didn't have a calculator that had a tangent button like that. Well, you could take the sine of 12, divide by the cosine of 12. It takes a little longer to type it in, but it comes out exactly the same. Sine divided by cosine is always the tangent. And if you flip it, cosine over sine, that's the cotangent. Because when you flip tangent, you get cotangent. That's what we just set up above. Okay, that's the second group of fundamental identities. The first group is with a reciprocal, which we've been using all along. And even this one we've kind of been using when we do unit circle trig. I just didn't call it an identity, but we've kind of been doing that all along. Sine divided by cosine. Now, the last group of identities, I'm just going to have you write them down. I'm not going to talk about them at all today. Okay, and they're not going to be on the test. The reason I'm having you write them is so you have all the fundamental identities on the same page in your notes. Okay? So at some point, we'll talk about these. I just want you to copy down those three. But I'm not going to talk about them today. So the first one says sine squared plus cosine squared equals 1. The second one is 1 plus tangent squared equals secant squared. And the third one is 1 plus cotangent squared equals cosecant squared. So when we study identities in more depth in the future, now you've got a page with all the fundamental ones all together. Okay, so this is, wherever you're writing these, this is an important page that we'll come back to. Okay, so I've given you a bunch of different stuff. Basically, just giving you a bunch of formulas. I'm going to show you a very straightforward example of what you can do with them. Okay. Anyone still need to copy anything or need me to scroll back up? All right, so we got two problems we're going to look at. Let's look at this. So the directions here say simplify, and it's cosecant times tangent. This Greek letter theta, it just represents an angle. What angle? Any angle you want. You don't use numbers with this. So it could be 10 degrees, 20 degrees. What I'm about to do works for anything. Okay. What I want to try to do is I want to rewrite this. But I don't want to write it as cosecant. I want to try to write it with either sine or cosine. So if you go back and look at that page of formulas we just wrote down, don't worry about the Pythagorean ones. We're not using those. Is there another way you can write cosecant with just sines and cosines? Yep, what is it?
Maybe 1 over sine.
It's 1 over sine. All right, so I'm going to start with that. Now I'd like to do the same thing with tangent. I would like another way to write tangent. So if you look at your formulas, I'm going to look for one that says tangent equals, and I think there's two to pick from. I would like the one that has sines and cosines in it. Shot?
Sine over cosine.
It's sine over cosine. Now, we're going to multiply those together, but when you multiply those together, it's kind of like this. 1 over 5 times 5 over 8. What would happen when you multiply two fractions together and you have the same thing in the top and the bottom? It cancels out. So this would just be, the answer would be 1/8 if you were doing it with numbers. Well, what cancels out here? Sine. Sine in the bottom, sine in the top. The reason it cancels is because you are multiplying. If you change the symbol between them to addition, it doesn't cancel at all. That doesn't work. Now you have to find common denominators. That's a whole different thing. But as long as you're multiplying two fractions together, you get the same thing in the top and the bottom, it cancels. What's left in the top? 1. What's left in the bottom? Cosine. And if you look in your notes, 1 divided by cosine, we can write that so it's not a fraction. Anybody see what it is? Yeah?
Secant.
It's secant. And that's the answer. So what we did is we took something that was kind of complicated, two different trig functions multiplied together, and we wrote it as one trig function all by itself. Any question on that? You try. It's a little weird. It's a little different, but we'll try another one. Let's see. Let's try 7, 8, and 9. All right. Well, let's try 8. It's kind of the same thing as 7. So the trick here is always to take what you have, and if it's not a sine or a cosine, rewrite it so it is. Okay, so let's start with secant. How can you rewrite secant? Yep, Jake?
1 over cosine.
Yes, it's 1 over cosine times. Now the second one already is cosine, so I'm not going to change it. But what if I wanted to make it a fraction?
Cosine over 1.
I could just put it over 1, so it doesn't feel left out of fraction land. But now it's a fraction. Am I multiplying between those two fractions? Yep. Do I have the same thing in the top and the bottom? Yep, then I can cancel it out. And I'm left with 1 over 1, which is just what? 1. So this time when we simplified it, all the trig disappeared and you just get a number. That usually doesn't happen. But it did in this case. Any questions on that one? All right, and let's look at this one. This will be our last one. Cotangent divided by cosecant. Same directions. If you see anything there that's not a sine or a cosine, let's change it so it is. Start with cotangent.
Cosine over sine.
Yep, you can write cotangent as cosine over sine. And how about cosecant?
1 over sine.
That's 1 over sine. And now you're dividing a fraction by a fraction. That's just like doing this. When you want to divide by a fraction, what do you do instead?
Multiply by a reciprocal.
Multiply by the reciprocal. What happens to the top? It stays the same. You don't do anything to the top. And Michael, what's the reciprocal? Because you said multiply by the reciprocal. What is the reciprocal?
Sine over 1.
Sine over 1. Okay. We have two fractions. Are we multiplying them together? Yep. Do we have the same thing in the top and the bottom?
Yes.
Yep. What's in the bottom? What's in the top cancels out. You're left with cosine in the top. You're left with 1 in the bottom. But cosine over 1 is just, it's just cosine. Okay. So we started out with kind of a complicated looking thing. It had two different trig functions divided. Oh, it's like your phone. You can like pinch it. Kind of.
I think yes.
If it feels like.
Interesting. So anyway, started out with something that looked kind of complicated. We finished with something that looked a lot simpler. That's the goal. So there'll be one question like that on the test, just one of those. And that's trig identities. That's kind of its own separate thing. Okay. Any questions on that? Okay. So the homework is mostly in the book, except I'm going to give you one trig identity to try to simplify. I don't have to? Well, I want you to have one of them at least to practice because it is on the test. And then we'll talk about what's on the test. I'm going to come right back to this. I just need to see which ones we did. We did secant times cosine, cosecant times tangent. All right. It doesn't matter what you call the argument. You can call it theta, call it x, call it q, whatever. I want you to try to simplify cotangent times, let's see, sine. It should be pretty quick. All right. So let's talk a little bit about what's on the test. Okay. I'll put this part in the video, so if you want to go back and look at it and remind yourself of what's on the test, you can. But let's see. All right, so on the test, there's only 2 sections. Okay, it's only on 6.1 and 6.2. Does everybody have the homework? All right, so kinds of things you want to know for the test. I'm going to give you a problem that says something like this. theta is an angle in standard position. Find the terminal side of theta. If, and now I'm going to tell you something. I'm not just going to say the angle is like 100 degrees and then figure out where the terminal side would be. I'm going to say something like the cosine of theta is positive. So I'll tell you that whatever this angle is, if you took the cosine of it, it would come out positive. And the tangent of it would come out negative. So I'm giving you a couple facts about it. Cosine would come out to a positive, and the tangent would come out to a negative. So if we remember cosine, what is cosine again? What in the unit circle?
X.
It's x. So that tells you right there, if you think of this as a coordinate, the x value is greater than 0. That's not enough though. What quadrants have an x value that's greater than 0?
1 and 4.
1 and 4. So we've narrowed down the answer to either 1 or 4. Now, what about the tangent? What's the formula for that?
Sine divided by cosine.
And what is that using the letters? But yes, you are correct.
Y divided by x.
It's y divided by x. And y over x is less than 0.
So that means y has to be negative.
So if x is positive, we already know that from up above, but y divided by x is negative. What does that mean y has to be? Y has to be negative. So x has to be positive, y has to be negative. What quadrant is that? That's quadrant 4. And that's the answer. That make sense? You just have to think about these in terms of letters, and then the x and the y tell you which way to go.
Can you just do another one like that?
Let me try to get through one of everything that's on the test first, and then if I can do a second one, yeah. Let's find the cosine of 49 degrees. Okay. Could you use the unit circle to do that? No, why not?
Because
It's not a multiple of 45 or
30.
30. So, use the calculator. First, make sure you're in the right mode. Now I'm in the right mode. And then type in cosine 49. And that's it, 0.66.
Will you always want us to round to 2 decimal places?
It could be 3 if you want me to. It could be 2 or 3. So this would be 0.656 if I did 3. But it'll be 2 or 3. How about find the cotangent of 12? What would I have to do first on here? Yep.
Make sure you're in radians.
Make sure I'm in radians. All right. And how would I type in cotangent of 12?
1 divided by the tangent of 12.
Yes. 1 divided by the tangent, and that's negative 1.573. Okay. Do you have a couple just like that? Let's see. Next thing we talked about arc length. So make sure you know this formula. Okay. Yeah.
Wait, on the last one, I got like a slightly different answer, like 1.48.
And you typed it in exactly like that?
No, I typed it in with the negative, the cotangent button on here.
That's
Okay.
inverse tangent, which is these negative ones up here.
Yeah, with
Those
the-
are totally different.
Those are okay.
Yeah, I'm not even going to talk about those today. It's a good guess. I can see why you would use it, but that's not what you
All right,
use
yeah,
it for.
just check it.
Okay, so you'll have a problem with arc length. I'll give you 2 out of 3 of the things, and you'll have to find the third one. Somebody pick a letter, and we'll solve for it.
Yes.
S. All right. Somebody pick something for R. 13. So my radius is 13 inches. And pick something for my angle. 5 what?
Degrees.
Okay, perfect. 5 degrees. Find the length of that arc. What's the very first thing you have to do there?
Convert degrees into degrees.
Yes. You have to change degrees to radians. So off to the side, multiply by pi, divide by 180. I would just leave it like that. Just use that as your angle. You can reduce 5 and 180, but if you reduce it wrong, then now you got it wrong. So r is 13. My angle is 5 pi over 180. And let's see what my arc length is. So 13 times 5 times pi divided by 180. 1.13. And that's, what was S again? S stands for arc length. So that's 1.13 inches. Because my lengths in this problem were measured in inches. So you're going to have an arc length. Okay, I'm going to give you a couple like this. I'll give you a coordinate. Like, let's do this. And I'll ask you to find a couple trig functions. Let's do an easy one. What would the sine be for that? Yep. Square root 3 over 2. Let's do a harder one. Now, normally to get the cotangent, I would just take the tangent and flip it. But I don't have the tangent, so I just have to do this from scratch. What's the formula for cotangent?
Cosine or sine.
Yep, it's cosine over sine, and cosine is which letter? The x, yep, which is a half. And the sine
Square root of 3 over 2.
is the y, which is the square root of 3 over 2. 2's cancel. And what's 1 divided by the square root of 3?
Square root of 3 is over 3.
Square root of what?
3 over 3.
Yep. Perfect. So you'll have a couple just like that. All right, angular velocity. So we talked a little about that. Let's say we have a wheel with radius 5 inches. Now be careful if they give you a diameter, because if you're thinking you have to find circumference and you use the formula 2 pi r, remember 2 pi r is 2 pi times radius. So this one's okay. But what if they gave you a diameter? How do you change it to a radius? Just divide it by 2. Okay? So just pay attention to that. So you have a wheel with a radius of 5 inches. I want to know how far would it roll I don't know if in is the right word, but how far would it roll in 4 pi radians? Well, it would be easier if I could think of how far it rolled in terms of what? Not radians, but degrees would be okay, but there'd even be something easier.
Rotations.
Rotations. How many rotations is 4 pi, or revolutions? So let's change that to revolutions, and that'll make it easier to think about. 4 pi radians. Where would radians go to cancel? Bottom. Revolutions in the top. How many radians in one revolution? 2 pi. 2 pi goes into itself once. 2 pi goes into 4 pi how many times? Twice. 2 times 1. So this is rolling 2 times. It's making 2 revolutions. So I'm just going to put that right below it. So what do I have to know to figure out how far it rolls? Like just one time. I have to know the what of the wheel.
Circumference.
I need the circumference. So the circumference is 2 pi times 5. That's the circumference of the wheel. It's a little over 30 inches. Now this wheel is rolling how many times?
2.
2. It's making 2 revolutions. So what would I do with my circumference to figure out how far it would roll?
Multiplied by 2.
multiplied by 2. So this wheel would roll 20 pi inches. If this wheel was on the ground and it rolled 2 times away from you, it would be about, well, 20 times 3 is 60, so a little over 60 inches away from you. Okay, but it's helpful to have it in revolutions. All right, so we got that one. Oh yeah, coterminal angles. That's an easy one. Find an angle, coterminal, with 40 degrees. Positive and a negative. So we actually just mentioned this. What do you add or subtract to an angle to find one that's coterminal? And this one is degrees. 360. What if it was radians?
2 pi.
2 pi. So let's take 40 plus 360. That gives me 400. And then take 40 minus 360. Gives me negative 320. Okay, so you want to make sure you know how to find coterminal angles. It'll probably ask you for one of the other, not both. Could I do it again? Could I add 360 another time or subtract it another time? Yeah, I can do it as many times as I need to till I get an answer. They'll say in the book, like, get an answer between 200 and 300, or get an answer between 300 and 400. They'll tell you where to get it. Okay, there's going to be a bonus. I'm not going to tell you much about the bonus, but I'll tell you that it's something you can do on, we only learned how to do it on the graphing calculator. So it's a set of things you do on the graphing calculator. And it's from last academic week. I'll even draw a picture and kind of give you another hint. That's all I'm saying about the bonus. If you don't get it, it's fine. It's just a bonus. And the last type of question on the test is a trig identity. That's like the last thing we did. Like the sines cancel or the cosines. Okay. So that's what's on the test. So there's 8 different topics. Some topics will have 2 questions, so the test is about 14. It's about 14 problems. Yep.
Are there any conversions?
For conversions, the ones you would need to know, anything with basic units of time.
Okay.
You should know how many seconds in a minute, how many minutes in an hour, how many hours in a day. You should also know how many radians in a revolution, how many degrees in a revolution, 360 or 2 pi. That's pretty much all you would need to know for conversions.
What was the first topic?
The first topic was this idea, finding where the terminal side of an angle would be. Okay, so I'll put that up on the video. I'll also double check yesterday's video and put that up because I think I forgot to. So if you need that, I'll put both videos up in about 5 minutes.